Yeah, so good evening, students. Welcome to the 10th session of this particular light chapter, student. So we have done 75% of this chapter, student. Everything is done. 75%. I can sure you can take any previous question paper up to mirror, you will be able to solve it. 100% sure. If at all you have understood everything, right? Okay, so today we are going to the session number 10. Let me give a quick recap. What is session number 10? We are going to introduce lens, image formation cases of lens, student. Okay, but before that, I need to cover some applications of the mirrors. Like we have done the mirror, so where are we using this particular mirrors in our real life? Okay, that is what I'll discuss it. Then I'll move to the lens. Okay, student. Okay, let me give a quick recap all what all happened in this particular week. Very important week, very important sessions are going on. Today's session is also very important. Okay, so student, we have started this week with spherical mirror terminologies and some image formation cases of mirrors. Okay, so we have taken convex mirror, concave mirror. We have also seen this particular sign convention where yesterday we have done many questions. Each and every question, the sign convention is very important because there will be no question without this help you can take, because always you should go for the polarities plus or minus. This Cartesian coordinate system will help us a lot. Okay, then we went to ray number one. I want to just again discuss all the four rays. What is ray number one, student? As per here, whenever light is coming parallelly to the principal axis, after hitting, it should go through the focus. It should go through the focus. That is what we read and we have seen in this beautiful diagram also. Okay, you can take a concave mirror, student. Whenever light is coming parallel, after reflecting, it is going through the focus. That is ray number one, rule number one. Okay, then what is rule number two or ray number two? Whenever light is going through the focus, after reflecting, it will go parallel. It will go parallel. Okay. So rule number two, student, whenever we, yeah, rule number two, whenever the light is passing through focus after reflecting, it will certainly go parallel to the principal axis. This is rule number two or ray number two also you can call. Ray number three, whenever light is going through the center of curvature, after reflecting, it will bounce back in the same medium. It will bounce back in the same medium. That is what we have seen the rule number three. You see, light is passing through the center of curvature. After hitting, it is just bouncing back in the same path, student. That is rule number three. Okay. Rule number four. Whenever light is hitting directly on the pole, it will just be symmetrical. It will just be symmetrical. Theta, and if you either look left side, you either look right side, both sides it look as similar as that, student. Okay, so look at here exactly rule number four. Okay, now why did I repeat this particular rules? Are you looking at the first time? No, we are not looking at the first time. We have seen many times. Why? Because we are again going to use these four rays in today's image formation cases. Okay, yes, then we have completed concave mirror, student. Concave mirror, six cases. Each case means you are moving object near to the mirror, and we have seen all these six cases, and I asked to remember each and every point of this table. If you are not able to remember, the simply shortcut is this, where object at infinity, image at focus. Object is now yellow color, orange color, image is moving left side, orange color. Now object is something like this blue, image has moving blue. Now object is still red, image has moved still left. Okay. So whenever your object is moving left to right, your image will be moving right to left, except the last case is an exception. Very important. This was the story with the concave mirror. Okay. Then we have started convex mirror also, student. Convex mirror. This is what the convex mirror is. So in the convex mirror, I said only two cases. Like concave mirror, we are having six cases. Concave mirror, convex mirror will have only two cases. First case, object at infinity. Remaining all are case number two, beta. All are case number. Why? They all will give same image characteristics. So if you keep object at infinity, where will your image be formed? Your image will be formed exactly at focus. And after that, you keep object anywhere, your image will be formed between pole and focus, where we have seen it. Where we have seen it, student. Okay. So 1 second, let me show that case also. Yeah, image formation cases. Yeah, this one. If you keep object at infinity, your image is at focus. When you keep object anywhere from the infinity to the pole, your image will be between pole and focus diminished. Okay, this is what I asked to remember. Okay, then we went to the very important numerical part, mirror formula and magnification formula. I asked to remember 1 by b plus 1 by u equal to 1 by f. Mirror formula, a magnification formula, hi by h naught or minus v by u. And we have done lot of numericals on this. Okay, this is what all happened in last 3 sessions, I guess, student. Last 3 sessions. Any doubt in any session? Any doubt? No. So we have done lot of numericals. So very important numericals. Okay. This is where that differs you from the normal student and a high average student. Okay. Why? Because 5 mark or 6 mark question, 4 mark question will come from this topic, and the normal student or the average student may not do it. But definitely, if you have understood all my session, all students can do this. Okay. Okay, Shima. Okay, understood. Okay, so student, actually this is a continuation to my previous sessions. I'm not sure how much the students can understand who are attending, who just missed the session. Okay, because everything will be related from the previous session, previous last 2 sessions, not very previous. Last 2 sessions are totally related to today's session. Okay, students. Okay. So before going to the lens, let us understand where do we use these particular things. Where do we use these mirrors? Let us understand step by step. Student. Okay. You need to write only definition, but I'll help you with the step by step. I'll help with the step by step. Flashlights or search lights. Okay, student. Okay. So first of all, what is light, student? Suppose this is a light. So suppose this is a lamp. Obviously, the light rays will go in all the direction from this lamp. All the rays. Now, if I want to search an object, or if I want to focus an object which is very far, can this small lamp will help to pass that light rays to pass this much distance? No. Your light is focusing on all the direction. So rays may not go up to here and it may not be visible to me. Now, how can I make this particular arrangement so that my light rays will reach here? So that is nothing but you need to take a reflector, like a concave reflector or concave mirror. Okay, Vishnu Maya, if this is a concave mirror and you know this is the principal axis beta, suppose I'm assuming this is my focus. So I kept my bulb at the focus. What happens to the light rays which is receiving, which is coming from the focus? Light ray which is coming from the focus to this concave mirror, what will happen to this reflected ray beta? How the reflected ray will go?
Will it be perpendicular?
Perpendicular. There is no word perpendicular here.
Sorry, parallel.
Parallel, exactly. Whenever light is coming from the focus of the concave, this is a concave reflector or mirror. I have adjusted this light exactly on the focus. Whenever light is coming from the focus, just now we have seen, whenever light is coming from the focus, case number 2, I guess. Yeah, you see, whenever light is coming from the focus, after reflecting, it will go parallelly. Same here, student. As the light is coming from the focus, after reflecting, it will reflect parallelly. After hitting, it will reflect parallelly. After hitting, it will reflect parallelly. After hitting, it will reflect parallel. Like that, student, you can make an arrangement such that your light will go to farther distances. Okay, so you can see your flashlight, searchlight, all what they do, they generally make a small light only, but they will ensure that light is kept at the focus point of, at the focus point. And whose focus point? The concave mirror focus point. It is just kept at the focus point of the concave mirror. So now any light that is coming from the focus, after hitting, it will go parallel. After hitting, it will go parallel. Like that, all the light rays will be going parallelly, so that the range of the torchlight or the flashlight or the searchlight can be increased like this. Yashashvi, did you understand how is this happening?
Yes, sir.
Okay, Rishit, any doubt?
No, sir.
No, okay. So that was the use of applications of concave mirror, student. Okay, it's not only that particular flashlight. Whatever you have a light in the particular front on the bumper of your car, you see any light will always use the light in all direction. But this particular light will have a concave mirror here. And what does that concave mirror do? They are adjusting that concave mirror, and the bulb is exactly placed at the focus. Any light that is coming from the focus, it should go parallel. Any light that is coming from the focus, it should go parallel. By that mechanism, the particular driver can watch the the range of the light can be increased a lot. So search flashlight, searchlight, headlight, they're all using concave reflectors. Concave reflectors. Pranav, did you understand this?
Yes, sir.
Okay, concave reflectors. Okay, student? Yes. Telescopes. So, student, telescope, obviously we use it to watch the far distance object. Anyhow, only concave mirror will definitely not help. There are many lens, many mirrors, but still they are using some concave mirrors where where it is help to see the enlarged images. So you see concave mirror. Is that the primary mirror? This one, right? This one concave mirror they are using, and how they are using, that's not our part of journey, student. So just you try to remember, telescopes are using some concave mirror. Not only concave mirror will not suffice the requirement, they are using many lens also, but it is not in our topic, so I'm not discussing a lot. Okay, so yes, Sai Chitra, in concave mirror if they are using enlarged images they were waiting, which cases are that? Concave mirror, now they want to see the small object to be enlarged. So which case of concave mirror they generally use it?
Four and six.
Wonderful, absolutely right answer. Okay, so obviously student, so she said that, sir, concave mirror you want to use, we have only two cases which are enlarged. You see exactly between C and F, this red color is here, it is enlarged, and the sixth case is here, enlarged. Obviously they might be using these two cases only, not the other cases. Okay, so that's the application of the telescope. Okay, student. Yes, solar furnaces, student. Solar furnaces. Okay, so let me see. Okay, I'll try to draw it here. Okay, so student, you might have seen that particular solar panels also. You might have seen, what does that solar panel do? Okay, whenever there is a sunlight, sunlight falls on this particular. Okay, sunlight. Who is it? Okay, whenever that particular sunlight falls on this particular panel, it will convert that particular light into electric energy. Okay, this is a solar panel. Whenever sunlight falls on this, this particular panel will convert into electrical energy and store that electrical energy in the battery. And from the battery, we use it for the different purposes of our household activities. This is what the solar panel will do. Okay. Now, student, you see, if there is a sun, hardly some 2 rays or 3 rays or 10 rays will fall on it, but not more than that. But many rays are just going side by. Much light is wasted, beta. Much sun rays are wasted because sun, obviously it will go in all direction, and many sun rays are. What if I'll ensure that these all rays are also falling on this particular, these all rays which are going side by, they are also falling on this particular solar panel. Now more light will fall, more energy will be converted, and more we can use that energy. So how can we ensure the right rays which are going side by, they are falling on this particular solar panel? So that is where this reflector mechanism comes. You see, student, reflector, sun rays, definitely they might be reaching that solar panel. It might be converting into electric energy. That is totally fine. But most of the sun rays are going side by also. Okay, okay, Rishit. Now you see, how are these rays, beta? How are these rays to the parallel? How are these rays to the principal axis of this concave mirror? How are these rays?
Parallel.
Parallel. So what happens if a parallel ray hits on a concave mirror?
It passes through focus.
Very good. Okay. So we have seen that whenever light ray travels parallelly, after hitting, it will pass through focus. Same mechanism, student. They will ensure this particular, whatever the panel is there, it is exactly kept on the focus. Now, hundreds of rays which are coming parallel to the particular thing, after reflecting, they'll go to the focus. After reflecting, they'll go to the focus. After reflecting, they'll go for like that. This particular panel is getting thousands of rays now. In spite of 10 direct rays, indirectly it is getting thousands of rays, more heat, more energy conversion. This is how the solar furnaces are taking help of concave reflector and maximum conversion is happening. Vishnumaya, understood beta?
Yes, sir.
Okay. Anybody I'm missing? Seema, are you able to follow beta?
A little bit, sir.
Little bit. Okay. Take the best advantage of my recordings. I'm again happy to share the recordings provided. You need to send me the note. And Yashashvi, you are having your holidays. If you are not able to complete chemistry and maths first two chapters in the holidays, believe me, after you start your school, you will not be able to complete. Why? Because you have the other subjects, you have other projects to deal with. So make the best utilization of your holidays. Okay, so students who
Okay.
who have missed or who have joined late, now it's up to you. Make the best use of such holidays. Okay, yeah. So student, definitely this we have seen it, student. We have seen already this case. So where you take a concave mirror and ensure that you are at yes, SSP, which is the particular case where I can use concave mirror for the shaving mirror or the parlor mirror. Which case is that?
Sir, case 3.
Huh? Case 3 means exactly same size of the object, same size of the image will happen, beta. I want that every part of the skin should be enlarged and
Case 6,
enlarged. Case 6
or 4.
enlarged. No, not a 4, beta. In the 4 it will be ulta. Your face will be seeing ulta. Do you want to see your face ulta?
No.
No, we require only case number 6. Okay. So this particular case is utilized for the shaving, what we call shaving and makeup for that. Okay. So student, you see, this is a mirror and yourself is an object. You are very near to the mirror. That means case number 6. Your object, this is a mirror. You are very near to the mirror. That means case number 6 is helping you to utilize that particular thing. Okay, students. Sure that you have all understood. Let's go to the another application. Yeah, so ophthalmoscopes. Okay, so nothing but the eye specialist student, ophthalmologist. Okay, so obviously he need to see deeper inside the retina. What are the particular problems, issues that is happening in your eye? Obviously, he need to use some instrument. That instrument is known as ophthalmoscopes, and you can see here is the mirror, concave mirror. Obviously, I'm sure that he might be also be using case number 6. He want to see this particular retina which is very near to the mirror he will be keep, and he want to see enlarged and virtual image. Why virtual, student? I don't want to get confused. These are very sensitive parts. I don't want to get confused. So that's the reason he is using case number 6. He is keeping very near to the eye. So your eye is an object. This is a mirror and very near to the object. Then only he can see virtual and magnified. Rishit, are you following? Case number 6.
Yes, sir.
Okay. Not only that, student, yeah, this is a classic example which you have already seen such type of arrangement. Maybe not right now, but 5-6 years before, whenever we are using cable connections or DTH connections, we are finding this mechanism. Now, what they are doing, okay? So these all are nothing but satellite communication, student. You see, from the satellite, if there is a signal coming, so this is a receptor. This is connected to your TV actually. Okay. Now you see the rays which are coming from very farther distance, they are definitely a parallel rays. So how many parallel rays are reaching? Only one parallel ray. If only one signal is reaching, if this particular receiver is connected to your TV may not be showing a bright images or a dull fade image you might be seeing on the TV. Now, sir, how will you get a good clarity image? Obviously, more signals should be received on this particular receptor. How can I increase this receiver size? No, it will be very costly and it may not work the purpose. So what we will do, we will ensure this is kept at the focus point of this big concave reflector. It will ensure that it is kept on the focus point of this big concave reflector. Now what will happen? Any ray that is hitting this particular concave mirror, so they are coming parallelly. After reflection, it would go to focus. Any ray that is going and hitting this particular reflector, so their parallel ray, after hitting, it is going to focus. So initially there was one signal coming, now there will be 30 signals coming. Obviously, you will be getting the best clarity image in your TV. This is how these concave reflectors are helpful for that particular satellite dishes also. रिद्धिमा समझ में आया बच्ची? Okay. Okay, yeah. Today only I went to the dentist for this cavity. You see, he was using some mirror. Perfect case is that mirror should be again a concave mirror. Okay, yes, Sai Chaitra. Which case of the concave mirror he might be using to diagnose that cavity?
6.
Very good. Okay, so student, obviously the nerves inside my these teeth are very, very sensitive. He should not get confused by cutting another nerve. So obviously this particular mirror, whatever he is using, definitely that's a concave mirror. Case number 6. Case number 6. Yes, Ridhima, why don't he use convex mirror? Why he's using concave mirror only? Convex mirror is no confusion, always virtual, but why don't they use it? Why he is using concave mirror? Case number 6 only. Sometimes if at all he is bringing the object, he is bringing that mirror, these all may give the inverted image, he may get confused, but still he is using concave mirror only. But why not convex mirror?
Because the image appears to be diminished.
Very good, absolutely right. Okay, so student, convex mirror, even though that is absolutely fine, so there will be no confusion, only two cases, and both the cases will give the virtual image only. But the issue is it will be diminished. I want to see the maximum image. My object is this, my image is this. My object is this, my image is this. In both the cases, it will be diminished, but I want to see the enlarged image. That's the reason, student. Obviously, he might be using case number 6 case. Okay, like that. These all are the applications what we generally use in our daily life. So please write the headings: headlights, flashlights, telescope, solar furnaces, shaving and makeup, ophthalmoscope, searchlight, satellite dish. Okay, for CBSE you may get it for 2 marks. For SSC Telangana, if you will be getting this for 4 marks, you need to give one line explanation also. One line explanation, not only headings, one line explanation also you need to give. Please write the only the heading, students, headings. So Ritika has sent me yesterday a note. So today, whom should I ask? Vishnu Maya. Will you send your notes? Vishnu Maya, please send your notes today. So no, don't say, sir, today only I did not write.
No, sir.
Okay, please send it. Okay, these are the applications of concave mirrors. Okay, obviously convex mirrors also we can use somewhere. Can anybody give where do we use convex mirror? Before me explaining, one hint, open question. Lavanika, Pranav, Riddhima, Rishi, Ritika, Sai Chaitra.
Near sharp turns, sir.
Very good, right answer. Absolutely right answer. Near sharp turns. Yes, Shima.
Sir, vehicle mirrors.
Very good, absolutely right. Vehicle mirrors. Okay, perfect. Okay, so this is what the convex mirror generally we see in our real life. Okay, so where do we use it? Large offices, stores, and hospitals, or near the turnings, whatever Yashashvi said. Okay, to prevent accidents or collisions. Okay, so students, you see, when there is a large building, actually assume that he's in a hurry. He wants to just rush up. He will just observe this mirror. Now, what is the advantage of this mirror? The advantage of this mirror is big region can be shown on the very small place. And another advantage is it is always virtual. मतलब सीधा का सीधा ही चाहिए इनको. He should not get confused that the person is coming in from far. If at all he is seeing the inverted image, again lot of confusion will happen. So at large offices, stores, especially during the road turnings, we want the big area should be seen in a small area, and always it should be virtual. मतलब erect, सीधा का सीधा ही दिखना चाहिए. So that time, what is the best case? What we have is convex mirror. Why? You can look at it here, student. In both the cases, we have big person or big area. Definitely, it will be small area, and we have here also in case number also it will be diminished only. Big area can be focused on a small place. Big area can be focused on small place. And both the cases or all the cases, it is always virtual. Virtual. मुझे सीधा का सीधा ही चाहिए. I don't want to get confused. That's the reason we are using convex mirror for these particular cases. Okay, student. So not only that, you see rear view mirrors, what Shima said. If you are watching this particular car, in spite of this convex mirror, if you concave mirror, these all cars will be appearing ulta. And sometimes when they come very near, suddenly it becomes very big. Why? Case number 6. If they come very near to the mirror or to your car, suddenly it will become big and that too erect. Okay, so that's the reason. To avoid the confusion, we will be using only convex mirrors. Convex mirrors. We want that big area to be covered, on the small place, and we want everything virtual and erect. Rishit, understood better why we are using convex mirror?
Yes, sir.
Okay. Okay, so smaller, upright, further. That's the reason we are using convex mirror. Not only that, you see, especially during the ATMs for security purpose, always convex mirrors they use. Why? Now suppose there's a big ATM and he want to just plug in his password. He can't watch always backside who is there or not. He'll just have a view on this small place where entire room can be monitored and he can happily click on his card and plug in his passwords. So big room can be shown on small place. And also, you don't want to get confused by looking this person ulta. We want everything to be virtual. So for security purposes, especially near ATMs, and when one single guard is there and he want to monitor big area, there also you see convex mirrors will be placed. Why? That guard can't see whole places at a time. But when the everything is focused on a one small place, he can just monitor that particular mirror and he can take care of the surroundings. So especially during the security purposes, we are using convex mirror. Okay. Not only that, even this is one case under vehicle search mirror. We want the big area which is car is with the particular car should be focused on a small place. So there also we are using convex mirrors. Okay, Ritika, following beta. Okay. Okay, so today there are no numericals. All is entire is theory today. I'll ask in the middle one or two numericals, one or two questions. Okay, so this is what we have completed for all the thing, everything about mirrors today. Everything about mirror we have completed. You see, we have started with reflection. Why? The mirrors are following the phenomenon reflection. This is how we have understood what is reflection, what is plane mirror, what are the terminologies. Then we have seen in very deeply convex and concave mirror and the numericals where mirror formulas and magnification. This is all we have covered, students. This is all we have covered. Okay. Now, where do we start? Let us go to the lens. Let us go to the lens. Okay. Obviously, student, lens are nothing but which phenomena they follow? They follow the refraction. They follow the refraction. And did we do refraction? We have done 3 sessions of refraction. Believe me, nobody will do 3 sessions of refraction. You take any course, you can see that. But that is required to answer the deep questions of Snell's law actually. Deep questions of Snell's law. Okay, so let me give a quick recap about refraction, then we'll start the lens, about the lens beta, image formation cases of lens. Okay, okay, so before going to the image formation of lens, let us learn refraction. Yes, Lavanika, what is refraction? Basic definition of refraction.
So refraction is the change in the path of wave when traveling from one medium to
Okay, bending of light, you can.
bending of light.
Okay, yes. Yes, Ritika, what is refractive index? Mu? Formula, either formula you give or layman language, both are accepted. What is refract? Just now she said the refraction is bending of light. Then what is refractive index? Anybody? Sai Chaitra? What is refractive index? Come on. Say. Yes, Vishnu Maya. Forgot.
Sin I by sin R.
My God. Sin A by sin R. Where did you bring this from? Pranav also is giving the same answer. That is Snell's law whenever light passes from two different mediums. But refractive index, yes, Lavanika.
So refractive index is the ratio of the speed of light in And from a rarer medium to the speed of
Yes,
light to the
yes,
density.
okay. Yes, so student, as per layman language, so just now she said that bending of light, as per layman language, how much is the bending is given by mu. How kitna bend hoga, how much it bend, it is given by mu, layman language. But if you want to say technically, sir, technically, it is a light ratio of light passing through the vacuum divided by light passing through that particular medium. That is a technical answer. Okay. So how much bending, how many molecules are very close to each other? Those all are nothing but refractive index. Okay. Then we have understood laws of refraction. Here you can say the second law of refraction is nothing but mu2 1 beta. Mu2 1 is nothing but mu2 by mu1. That means two mediums are there. What is the ratio of refractive index of one medium to another medium? It is given by sin I by sin R. Anyhow, I did not ask you to remember this. I have asked you to remember Snell's law. Snell's law. Okay, Rishit, give me the Snell's law. Suppose here is a point of incidence. This is mu1, this is mu2. Give me the Snell's law how to write.
mu1 into mu2
mu1 into mu2.
is equal to constant Lexon value.
No, totally wrong. Shima. At the point of incidence, I'm asking to apply Snell's law. Are you there, Shima? Shima, Riddhima.
Yes, sir.
Acha, you're there? Yeah, go ahead, beta. Go ahead, Shima.
Sir, can you repeat?
So laws of refraction, second law is what is this? This one. But I have explained that law through Snell's law. So now I'm asking to apply Snell's law at this point of incidence. Yes, Riddhima.
Sir, I'm not sure.
Okay, Riddhima. mu1 into
Mu1 into sine is equal to constant.
okay, right answer. Okay, mu into sine theta equal to constant. Or else I said that mu1 light is coming from mu1 into sine. What is the angle? I equal to light is going to mu2, and what is the angle? R. Mu1 into sin I equal to mu2 into sin R. Now you can say sin I by sin R equal to mu2 by mu1. This is how the formula comes from. This is how the formula comes. Okay. So please try to recall the things. Okay. Yes. So whom should I ask? Yashashvi, were you there in my refraction?
No, sir.
Oh. Sai Chaitra, what is critical angle? What is critical angle? Forgot everything. Okay, I'm showing it
Sir,
here.
can I tell?
Largest angle of incidence.
So what happens to the refraction? Largest angle, what happens to the refraction? Yes, Yashashvi, go ahead.
Sir, if the angle of incidence is greater than the angle of refraction, then the the angle formed by the refractive angle, is will not pass to the rarer medium, sir.
Okay, that's not probably right. Okay, so student, as I said, first of all, light should pass from denser to rarer. Denser to rarer. Now you can see light is passing from the glass to air. So suppose this is a light coming from denser to rarer. Obviously, if at all it is passing from denser to rarer, what is the shortcut? DRA, DARA. It should move away from the normal. So obviously, light will move away from the normal. But if I still increase, this was the angle of incidence. But if I still increase angle of incidence, at one angle of incidence, my refracted ray will graze the surface, which is nothing but it is just grazing through the interface. So that student, this is nothing but critical angle. You can see this angle of incidence. So suppose I'm taking something like 30 degrees, your refracted ray, in spite of bending, it is almost bended a lot and touching the surface. Okay, Rishit, what happens if I still increase? So right now I said 30 degrees. Right now again I'm saying I am increasing 35 degrees. What happens? What is the criteria that happens?
Sir, can you repeat that question once again?
30 degrees is a critical angle beta. So angle of incidence is 30 degrees. I am able to see refracted rays grazing the surface. If I still
Yes, sir.
increase my angle of incidence, what will happen to the refracted ray?
Then it will change, like the total internal reflection doesn't happen.
Doesn't happen or happen? Okay, so whenever angle of incidence is more than that, total internal reflection happens, student. Happens. Okay, look at this particular thing. You see, first angle of incidence is 20 degree. It has bended. 30 degree. It has still bended. 60, 40 degree bended. Bended. You see, at this particular thing, you see, student, this one. At this one, it is grazing the surface. So this is nothing but critical angle. Now, sir, if I still increase the critical angle, what will happen? You can see that that light ray will reflect back. So this is total internal reflection. So whenever my angle of incidence, this one, angle of incidence is more than critical angle, the total internal reflection happens. Okay. So try to recall the things, check your notes sometimes. Okay. And if somebody who has missed the session, ask me the recordings. Okay, this is a quick recap about all the refraction what we have done for the 3 sessions. Okay, now let us go to the lens. Let us go to the, okay. So let us start with directly spherical lens, students. Spherical lens will start it. Okay. Okay, so there are how many types of spherical lens? There are 2 types of spherical lens in your class 10. Convex, concave. Convex is something like this. Concave is something like this. So how to just by looking how to remember the thing? What I use this, I said. Okay, in my class 10, I used to remember like this. I always forget this. I used to remember idli. How the idli looks like, in the center it will be bulged and the edges it will be sharp enough. So that is how I used to remember. But right now, if you want to remember, I'll give a better technique for that. So this is concave. Why? Light is coming through the cave part. So it's a concave. Okay, it is convex. Why? The light is coming on the bulged part. It is convex. Like that also you can remember. This is convex. This is concave. Okay, concave, concave, convex. Okay, so student, before going into the lens, what we need to know? We need to know the physical things. What are there? Obviously, the physical things will be same. Center of curvature, radius of curvature, principal axis, focus, aperture, except the last one. Last one is there is no word like pole. There is an optical center. Okay. Let me explain what is this. Okay. Let me just give a quick recap. So what is optical center? You see, if at all this is a mirror, so we have only one center. This was we were taking pole, but now student there is not there is some gap over here. We can't take this as center. What we need to take? We need to take this as center. This is the optical center. So in this center, again in this gap we need to take center. We call it as a geometrical center. Okay, I'll explain that point. Wait for that. Let me explain other points. Okay. Yes, Lavanika. So center of curvature. What is center of curvature, Lavanika?
So if we assume the spherical mirror to be a part of a whole circle, then the center of the circle from
Right.
which you draw the radius is the center of curvature.
Absolutely, this is center of curvature. If we assume this big sphere, this particular part is taken from the big sphere, the big sphere center is the center of. What is radius of curvature? It is again same from the center to the optical center is nothing but radius of curvature. Okay, you can just say here also, student, not that here also. Okay, so it's a radius of curvature. What is principal axis? You can say, sir, any line that is going through the center as well as optical center is known as principal axis. What is focus? Focus is nothing but whenever the light is coming parallel to the principal axis, it should pass to the focus. Yes, Sai Chaitra. So is it right, beta? Whenever light is coming parallel to the principal axis, it is going passing to the focus. That is known as focus. Is it right?
Yes, sir.
Okay. Ridhima, is it right? Whenever light is coming to the parallel, after hitting, it is going to the focus. Is it right?
Yes, sir.
Anybody who wants to differ with? Okay, Sai Chaitra, is there any paint here that it will reflect back? If this is a mirror, then you should say, sir, there is a paint, the light can't go other side. it should go to the focus. That's the reason this is right. But student, it's a lens. There is no paint here. So your light will go through like this. It's not right, but right now let me explain by this one. Why it is not right, I'll explain. Okay. So now you can say that, sir, so parallel line should go to the focus, but your focus is here. No, student, we have two focus, two center of curvature. Look at here. It is also one circle. It is also one circle. That's the reason. Here is also one center of curvature. Here is also one focus. Okay. Student, this is not right. Okay. Actually, this should be divergent. But right now, you assume, sir, light ray is coming parallel. It should go to the focus. It will not go through here. Why? It will not reflect. Here, the mechanism is refraction. Lens, the mechanism is refraction. You see, bending of light is happening, but it should certainly go to the focus. That is how it is going to this focus. And it is also focus of this sphere. Understood, Sai Chetra?
Yes, sir.
Okay. Okay. So that was a focus. Aperture, it is well understood that the particular this part beta from where the light can refract. So I'm not using the word reflection now. I'm using the word refraction. This particular part, or else I'll draw it. This particular piece is nothing but where the light can refract. This size is nothing but aperture. Okay. Yeah, pole optical center. Even though I already said that you take a convex lens and this is an optical center, and the definition is optical center of lens is geometrical center of the lens. You see, this is a geometrical center, but another definition is also there. Okay, so yes, Ritika, if I say that this is nothing but optical center, you have in your mind all the four types of rays. Which ray will change here? Which ray will change here? Ray number 1, 2, 3, 4. Think about 4 rays and then say me which ray will go, which ray will have something changes.
Sir, the one which passes through the pole.
Wonderful. Okay, so student, there we have a pole word, but here we don't have a pole word. Here we have a optical center. That's the reason, student. So whenever the fourth ray, whenever the light is coming and hitting the optical center, it goes undeviated. That point is called optical center. So optical center, he don't define only geometrical center of the lens. He says that if at all there is some light, I am passing through one point of the lens and the light is going undeviated. If at all there is a light and and there is one point, if at all I am passing that particular light through lens, it will go undeviated. This is nothing but the definition of optical center. Okay, so in the particular mirrors, this is what the change is better. Pole unit, it will reflect and the symmetry will be maintained. But here, this ray will continue like this. This ray will continue like this. Oh, sorry, here is the ray, right? This ray will continue like this. Okay, students. So, yeah. So, remaining 3 rays, no change. Okay. In the mirror also, remaining 3 rays, no change. If it comes here, sir, it should go through the focus. It will go through the focus. But this focus. Okay. If there is a focus, sir, if any ray that is coming through the focus after reflection, after refraction, it will go parallel to the focus. It's parallel to the principal axis, like this. Remaining all the rays are same, only the fourth ray will change. Okay, students. So shall we start image formation cases now? Okay, so yes, Yashasvi, which mirror is this?
Convex lens, sir.
Okay, very good. Convex lens. Okay, so let us start the image formation. So here, students, again there will be 6 cases. So let us take the convex lens and start the first case. Where should I keep? I should keep object at infinity. Yes, Lavanika, you can see, student, this is nothing but convex lens. Obviously, it should have one center of curvature, one focus, one center of curvature, one focus. What is wrong here? What is wrong here, Lavanika?
Sir, you should put focus first
Very
and
good,
then
very good, very good. Absolutely. Okay. So student, here also we have 2 things. focus should come first, then center of curvature. Why? The radius half करेंगे तो focus आएगा. This is radius. If you do it half, you'll get focus. Okay, that's perfect. Okay, Lavanika, help me, beta. My object is at infinity. Which type of ray will you suggest?
So the first ray should go straight.
Parallel ray. Whenever a light is going parallelly, as it is a lens, it should refract and it should pass through the focus. Why is one thing enough, Lavanika? Should I go for another
No,
also?
sir. Another one.
Yeah. So another ray, what will you consider?
Sir, it's the ray I always tell you, like below the parallel.
Parallel. Okay. As it is infinity, only the parallel ray is there is a chance that it will reach up to the lens beta. Again, after hitting, it should refract and pass through the focus. Okay. Yes. So where is the intersection happening? Intersection is happening here. Okay. Give me the characteristics, Lavanika. Image location. Where is the image formed?
At the focus behind.
At focus. At focus. You need to just give at focus. Okay. And how is the image? Big, small, point size?
Coin sized.
Point size. Okay.
Point sized.
Point size. Okay. And third one. How is it real or in virtual? Real or virtual?
Right. I think it is. Sir, it is virtual.
Virtual. Okay. You see, real rays came, real rays refracted. Real rays came, real rays refracted. So these two things are nothing but refracted rays. That means it is speaking about the characteristics of image. Are they appear to meet or actually meet?
So they actually meet.
Actual meet means what? Real. If it is real, what is another word that always comes with real?
Inverted.
Inverted. Okay, student. These are the characteristics of the image form. Okay, okay. Am I missing anything? Pranav.
Yes, sir.
Yeah, so student, you see here we have focus 1, center of curvature 1, focus 2, center of curvature 2. Even though I am able to see my image is forming at this focus, why is he considering F2 here but not F1? Or can we interchange it also?
Sir, what's the question again?
Question is why he is considering F2 here? Can I make this as F1, this as F2? We have two focuses, two center of curvatures. But you take any book, he will always consider where the image is formed as focus 2. But in spite image form means that should be given priority. It should be named as focus 1. But why is considered focus 2?
Sir, because focus 2 is positive.
So what? Focus 1 will be negative. Who stopped it?
Yes.
So is it negative word? Is it not considered? We have done many questions with negative also. That is absolutely fine.
Both have the same values. They can.
Values will be same, but he is only considering focus 2 as a main focus, but he is naming it as F2. Okay, so student, why? Because we always keep our object at left side, whether it may be mirror, it may be lens, and the object side is always taken as 1, 1. That's the reason, even though your image is formed at this focus, it is given name as F2. Okay, my object side will always start with C1, F1, all the story R1, and the other side will be 2s. Okay, student, that is the reason. Okay. What else I thought to say? Okay, no problem. So, student, you see, this is a classical example. Whatever you have done in your childhood, you would have done it or not. I have done multiple times. I have burned my sister's hand also one time. Okay, you see, this is a sun rays. This is a magnifier. Obviously, sun rays are always parallel. It is coming from infinite distance. So you can consider this as best example. Sun rays are coming parallel. You have kept the magnifier. Magnifier is nothing but convex lens. And what does it do? It will converge at one particular point. So all the sun rays are summing up at one point. So now student, if you keep a paper, this all the intensity is concentrated at one particular position, that paper will be burned. That paper will burn. If you keep your hand will be burned. So this is a classical example of case number 1 of convex lens. Okay, Ritika, understood beta?
Yes, sir.
Okay, yeah. Now next question comes is, yeah, yes, Rishit, object is here. Okay,
Yes, sir.
I'll take green color as object. Okay. Now, object distance is generally represented as u. Will u be positive or negative? Object distance.
It will be negative, sir.
Yes. So, what are you taking reference here? In mirror, you are taking pole as a reference. So, here, what will you take a reference?
Sir, can you repeat it again?
In mirrors, you are taking pole as a reference. You are keeping this pole at 0, 0. So, in lens,
sir.
what will you keep 0, 0 at?
At optical, what do you call
Very
it?
good. Okay, optical center is the reference. Okay, obviously from the left of the optical center, it is minus x-axis. U will be negative. Okay. Similarly, the image is formed here. So this image distance we generally call it as V. Obviously, it is right side. We generate it V as positive. Okay. So Rishit, what is focal length here? Positive or negative?
Sir, is it focus 1? Like,
So that is what I'm asking. So which one you will consider focus? Where is the image formed? Take that as a priority.
then it is positive, sir. Focus 2.
Positive. Okay, that is the reason, student. When I explained mirror, I asked only to write convex. Don't write convex mirror or convex lens. Why? Here also we are getting positive, and in the convex mirror, this is painted, and you have seen that, sir, whenever light ray is coming, it is reflecting, but it should ensure through faster focus, and we have taken this one. So whether it may be convex mirror ho, whether it may be convex lens ho, focus is always right side. So please just remember convex positive, convex positive, convex positive, whether it may be mirror, whether it may be lens. Don't remember the next word, only convex positive. Okay. Yes. Now let us go to the case number 2. What is case number 2? Object is between infinity and string. Yes, Vishnu Maya. Convex lens is here. I am taking this as my center of curvature 1, focus 1, focus 1, focus 2, center of curvature 2. I need to keep my object near to the center of curvature, or you can also say between infinity and C1. Yes, Vishnu Maya. I want to create an image. So what ray should I consider?
Sure, so the object is like beyond C, right?
Yes.
Then image will be between F and C.
Yes. Perfect. So she's already analyzing the situation. Very good. Tell me the ray better. Tell me the ray.
Ray,
Any ray.
the ray that goes through C.
This one, you see, probably that may skip the mirror, lens. So the ray should pass from the top also.
Or maybe parallel to the
Okay, parallel.
principal.
Okay, so you see, student, parallel ray after refracting, it should go to the focus. One more ray, beta.
Another ray.
Ray 3 you want to take? Okay, so Sai Chitra is taking ray 3. What is ray 3? So Lavanika, go ahead.
Sir, a ray that passes through the optical center.
Okay, you want to take optical center? Okay, so she's saying, sir, you pass the ray through optical center, and the specialty of that ray is it will definitely go undeviated. So where is my intersection happening? Here, and this is what Vishnu Maya said. Sir, the image will be formed between C and F. C and F like this. Okay, so Vishnu Maya, how did you predict it? How did you predict it? Yes, Vishnu Maya. How did you predict it? Hello, hello. Can you hear me? Okay, so student, you see, when we just check back these two conditions, sir, first condition, object at infinity, image at focus. When I just saw back it, and the second case, when the object is between beyond C, the image is between C and F. Yes, Pranav, is this image characteristic matching with? So right now we are discussing convex lens beta. Now,
Yes, sir.
is this characteristic matching with concave lens or concave mirror? Concave mirror or
Concave
convex mirror?
mirror.
Yes,
Convex.
concave mirror or convex mirror. Yes, Pranav, your answer is right. What did you say, beta?
Concave mirror.
Okay, so students, so please try to remember this convex lens is matching with concave mirror. Convex lens is matching with concave mirror. Okay, you see, diminish, ये तो छोटा हो गया, real inverted between C and F. When I go back and saw that particular, look at here, student. When I kept the object beyond C, what are the characteristics? Diminished, real, and inverted. Here also I am getting diminished, real, and inverted between C, F and 2F, or between F and C, between F and C. So these particular characteristics are exactly matching with the concave mirror. The convex lens characteristics are matching with concave mirror. Concave mirror. Okay, so that's the reason Vishnu Maya is already able to predict, sir, my image will be between F and C. Understood, Sai Chaitra?
Yes, sir.
Okay, so Sai Chaitra, help me, beta. Next case, I am moving my object exactly on C. So you can see this is a convex lens C, F, F, C. I am keeping my object at C, beta. So what is the final answer? Even before drawing the thing, where will the image be formed? Object at C. Image will be formed at
C.
Very good. Okay. So she already know the answer. C. Now, student, it is in your hand. You take any ray, try to adjust the cases. That's all. Okay. So what will I do? I'll take a parallel ray. So as it should pass the focus, I'll ensure that it is passing through the focus. Okay. And I should take another ray. So let me take another ray, something like yellow color. Let me take optical center only. Let me take. I'll ensure that it is cutting it here only. It is in my hand now. I already know the output. You just try to trace the particular rays and ensure that they are intersecting at C. That's in totally in your hand, beta. You already know the answer. Why? You're just comparing it with the concave mirror. Rishit, are you following, student?
Yes, sir.
Okay. Okay, so suppose if you are feeling, no, sir, I want to take the ray number 2. Some student has asked me, you can take ray number 2. You see, sir, this is focus. A light ray going through the focus, after hitting, what will happen? It will travel parallelly. You see, again the intersection is here only. So you try to adjust whatever you want because you already know the answer. Where will the image be formed? Where will the image be formed? You already know the answer. Try to adjust the lines or the rays like that. Okay, and obviously the characters are equal sized, and you see real rays are actually intersecting. Real, if the real comes, inverted comes, or you can also see the object is arrow is up, image arrow is down, and the location is exactly at C2, or you can also say 2F. Okay, SSB case number 4. Let me keep object between C and F, beta. Between C and F. Yes, SSB, where should be the image be formed?
Sir, beyond C, sir.
Very good. And how is the image, small or big?
Small, sir.
Between C and F, your image is C, big, magnified, case number 4. Okay. So you already know the answer. Now you arrange the particular rays according to your mind, according to your knowledge. Sir, I need to make them intersected here. You arrange it. Sir, I'll take a parallel ray. It should go to the focus. Parallel ray, it should go to the focus like this. And I'll take the optical center ray. I'll ensure that it is also hitting at the center. Finish. Because you already know, sir, this is center and my image should form it here like this. Like this. Yes, Shima, give the characteristics better. Image characteristics. So Shima, I think you have not appeared for the previous. I'll help you out. So image characteristics means there should be 4 points better. So first point, where is the image forming? Shima here, yeah.
Yes, sir.
Where is the image forming? Location.
Sir, between C and F.
Between C and F is this area better. But your image is here.
Sir, after F.
Beyond C, you say. Beyond C. Or you can also say, sir, this is infinity. Between C and infinity also you can say. Okay, so that is location. And what is the size better? Is it enlarged or diminished? This is object, this is image.
Sir, enlarged.
Enlarged. And is it virtual or real?
Real.
Real. Okay, so student, real ray came, real ray intersected, real intersection is happening. Or else you see, sir, my
Inverted
image, my image is inverted. I'm able to see clearly. If inverted comes, real comes. Okay, these are the 4 characters. Okay, so that is the reason I said, student, if you just remember concave mirror, the remaining will be exactly same. You see now convex lens, exactly you're giving the answer without doing also. Comparing with concave mirror, that's all. This convex lens. Okay, yes, Rishit. Next, my object is at focus beta. So this is a convex lens. This is center of curvature. This is focus. This is also focus. This is my center of curvature. I am keeping my object at focus. Yes, Rishit. Before doing, can you predict where will be the image form?
I think it at F, sir.
At F.
No,
At F means first case when my object is at infinity, then
no, sir.
it focus and focus. Then
Between C and F.
that is second case. My object is just beyond C, then your image will be between F and C. You see, you are moving image like this, you are moving object like this. Your image should also move. First case, here was the image. Second case, here was the image. Third case, here was the image. Now fourth case, where will be the image? You move the image also.
Like beyond, like.
Ritika, where will the image
Sir,
be?
the image will not be formed.
Image will not be formed. Okay, you can see this brown color doesn't have any brown color image, or else you can see at F your image, even though he said is forming at infinity, but he is giving clear indication image would not be formed in concave mirror. As this convex lens is exactly like a concave mirror, you need to ensure image will not be formed. How will you ensure? Take a one particular ray. Obviously, parallel ray is the best ray. It should pass to the focus. It is passing through the focus. Take another ray, generally fourth ray. It is optical center. It goes undeviated. Now you can see, sir, 2 parallel rays can never meet. They will not form the image. Sir, why don't you extend backside? Let me extend backside. Let me extend backside. Again, I got confirmed. Backside also they are parallel. Image will not be formed. And that is what you need to show like this. Image would not be formed. Okay, but still you see that fellow has corrected position of the image. It might be at infinity, or he would have given image would not be formed entirely. So again, NCRT, Ram Bharosa. He should have given directly image would not be formed. Again, he confused here in the updated syllabus. At infinity also is giving position of the image. Again, he is giving qualities, image would not be formed. In spite of that, he would have deleted this also. Entire he would have given image would not be formed. Okay, yes, case number 6. It's a very important case, as we have seen the concave mirror also. I am moving my object near the convex mirror. Yes, Ridhima, this is a convex mirror. This is center of curvature, focus, center of curvature. beta. My object is very near to the lens. Yes. Where will the image be formed?
Sir, behind the lens.
Here?
Like, mm,
Here behind the lens means lens behind means this is also behind lens. This is also behind lens.
like beyond C.
Yeah, you can see beyond C, beyond C.
On the other side,
That means you want to say first or second?
second side.
No. Okay. You see here. You see here what has happened? Till here the images are this side. Suddenly in the sixth case the image went on the other side. You can use the same phenomenon. Till here, till the case number 5, all the images are this side. So in case number 6, the image should form this side. Image should form this side. Okay. This is how the image is formed. Okay, I'll explain it. Okay, so student, I already know that till now the images are case 1 here, case 2 here, case 3 here, case 3 here, case 4 here. So now case 6, suddenly the image should be this side. Okay, image should be this side. That one clarity I already have it. But how to ensure that that particular thing follows? Again, you take two rays. First ray, better is the parallel ray. After hitting, it should pass the focus. Okay. Second ray, the best one is again the fourth ray. Again, you can see that they both are divergent ray. So will they intersect? No. But can we extend it backside also, and can we try it? If I extend it backside, yes, here is what the image form. Where are the rays coming from? Rays are coming from the arrow part. Construct the arrow and keep it over here. Keep it over here. Okay, keep it over here like this. Okay. Yes, Vishnu Maya, give me the characteristics.
Huh?
Characteristics of the image.
The image will be virtual and
You can see student
erect.
exactly. She is saying that, sir, you have extended there appear to meet. Appear to meet means virtual. Virtual means erect, or you can also see Sida ka Sida mil. Next,
And they'll be enlarged
enlarge. Obviously, we can see that. Okay, and where is the
um,
image form?
behind the mirror, behind the lens.
Behind the lens. Here also behind. Here also behind. Okay, so here we will take behind the object. You see, object is here. Your image is behind the object. Okay, behind the object you can take it, or sometimes he will say that behind the object, right? So this is also right, but he is using some other word. Let me see, student. Behind the object, on the same side of the lens as the object. That is also right. You can see object is also this side of the lens. Image is also this side of the lens. You can either say behind the object, or you can also say on the same side of the lens of the object. Both are right. Both are right. Okay. So student, convex lens, whatever the cases you see, this is an exact match with concave mirror. Concave mirror. Now, why like that? Question is, why like that? Concave mirror. You see the name, it's concave. But all the cases are matching with convex lens. Why like that? $1,000,000 question. Why like that? So by the name, at least it should match with concave lens, right? But why like that? Okay. Oh, very good. Who is this? Pranav. Super. Right. Think, student. Other students think. Why like that? Why they are matching? Okay. With that, we have completed convex lens. Okay. Now let us see concave lens, student. Let us see concave lens. Obviously, here also it's a perfect match with concave lens are perfect match with convex mirror. So that is the reason, student. Here also we have only two cases as we have seen in convex mirror. Okay. So the first case, object is kept at infinity. Yes, Ridhima, object at infinity beta. So what type of rays should I consider?
Parallel rays.
Parallel rays. So Ridhima, can you say that parallel rays is coming? Sir, as this is a lens, so center of curvature, focus, focus, center of curvature. Can I say like this, Ridhima? Is it right?
Yes.
Okay, anybody who wants to differ? Ritika, Pranav, Vishnumaya, Rishit, Sai Chaitra, Lavanika, Yashashvi, Shima. Is it right? Okay, Sai Chaitra want to differ. Go ahead, beta.
Sir, I think it moves away from the principal axis.
Very good. Okay, so student, this is just exactly opposite to the convex lens. You see, what did we learn in the convex lens first case? I'm going back, recalling the back things. You see, all the rays are converging. So after refraction, they should they are coming at one point. But now we are speaking about concave lens. They should be diverging. Student. Okay, so let me see that. So here what I drawn is totally wrong, sir. It will not converge. It will diverge. Okay, so that's the reason, student. My particular ray will go like this. But again, sir, you said that the parallel ray should always go and hit the focus. But how can you differ? You extend backside and ensure it is passing to the focus. Extend backside and ensure it is passing to the focus. Again, student, as it is only one reflected ray, one refracted ray, image will not be formed. Let me go for another parallel ray, and as it is a concave mirror, it should diverge. But again, sir, it's a parallel ray. It should go to the focus. Extend it backside. Ensure that it is passing to a focus, and this is what the actual figure is. This is okay. Okay. So yes, Rishit, help me with the characteristics of the image. Where is the image formed?
Between F and O, something. No.
You see, intersection is happening here. Where is the image
Between
formed?
infinite and
It is F beta, F focus. So why don't you use direct word at focus?
Yes, sir, at focus.
How is the image beta? Big, small, point size?
Point sized.
Point size.
Diminished.
Okay, now is it real or virtual?
Virtual appear to me.
Virtual. Okay, actual is going like this. We have extended so they appear to meet virtual. If they are virtual, what is another word?
Erect.
Erect. Okay, these are the four characteristics of the image or the first case of concave lens. Concave lens. Okay, now case number 2, you can keep anywhere. Yes, Ridhima, focal length of a concave lens, positive or negative?
Negative.
Negative. Okay, this is an optical center. My focus is here, which is left, negative. That is the reason, student, in the mirror I just said to write concave. Don't write mirror or lens. Here also, even though it is lens, it is negative. There in the mirror, this is a concave mirror. So this is the principal axis. This is the center of curvature. This is focus. And you can see from the pole, it is also left. So there also it was negative. Here also it is negative. Either it may be mirror or it may be lens. Whenever you see the word concave, you should remember negative. Vishnumaya, are you following, student?
Yes, sir.
Okay, case number 2. Yes, Pranav, case number 2. You already know it is perfectly matching with convex mirror. So where will be the image form, beta?
So the image will be formed between beyond C.
No, think. Yes, Sai Chaitra.
Between the focus and the object.
Object, no. Okay,
Optical,
here is
optical.
optical center. Okay, you see, these are the two cases, student. First case we finished. Object at infinity, image at focus. This is the first case of concave lens also because it is matching with convex mirror. Second case, you keep anywhere between infinity and pole, your image will be between pole and focus in case of convex mirror. So here also exactly similar, student. Here center of curvature, here focus, here center of curvature. you keep object anywhere like this, your image will be somewhere over here between optical center and focus. You already know it, okay? Now you need to just try to arrange the diagram, okay? So he has taken parallel ray. As it is a concave lens, it will diverge. But you know, as it is a parallel ray, it should pass to the focus extended backside. Now take another ray, optical center ray. As it is optical center, it goes undeviated. But student, even though it goes undeviated, from this part, I'll say it is a refracted ray. Why? It is going from one medium to another medium. It is not bending, but still it's a refracted ray. But now can I extend backside? Yes, I can extend backside. Where is intersection happening? Here. Where is the light coming from? Arrow, arrow, like this. So here also you can see image is formed between focus and optical center, and these are the characteristics. So we have intersected the dotted lines, virtual. If virtual comes, error comes, and it is diminished, and between focus and optical center perfectly. You see these two and these two are a perfect match. Convex mirror, concave lens are a perfect match like this, student, like this. Okay, with that we have completed all the mirrors and lens. Probably next week, Monday, maybe on Tuesday, I'll try to complete this entire chapter, and I want to start biology as soon as possible. Okay, any doubt in today's session? This is very, very important for the next session. Next session, I am not going to repeat it directly. Numericals, I'll say real and inverted, virtual and erect, behind the object. I'll be using these words. Okay, so try to recap the things before coming. Anyhow, I'll flash the particular slide screenshot on the day on Monday in your group. Go through them and come prepared so that we can go for the numericals on the same day. Thank you, students.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.